7.1 second half, which is on the law of sines. And in this half, we're going to focus on story problems. We've seen similar story problems, except now we can work with non-right triangles instead of only right triangles. We're going to apply the law of sines to each of these. The focus is not going to be on how do you solve them by doing the calculations. It's more going to be setting the problem up, writing down the law of sines correctly. Let's take a look at this diagram, which is number 22 on page 336. And you're going to see that you have two radii of the circle. You're going to have an arc length of 22, and you're going to have an angle outside of the circle, 26 degrees. And the question is, what is x? And when you're looking at x, you're looking at the length of that red segment. That is not part of any triangle. It's not a full length of a side of a triangle. It's part of a side. So you want to be careful when you set the law of sines that really you need to think about that whole side of the triangle. All right, so I have a side. I want to find another side, and I have an angle. That's all I have. I need another angle to help me use the law of sines. The other angle that you're going to find is this angle right here, theta. The reason why you can find theta is because it's a central angle, and we can find it in terms of radians by using the definition of radians. Theta equals S arc length over R radius. Definition of a radian is the arc length over the radius. So when I go through this, I'm going to see that it's 22 over 20, which is 11 over 10, or 1.1. I also have to remember that the law of sines requires you to use either degrees or radians, but not a mixture of the two. So I really want to convert that to degrees so I can use my calculator in degrees. And so theta is the same thing as this in radians. I could put a little r there to remind me, times 180 degrees over pi radians. And you would see that the radians would cancel, and you're left with 1.1 times 180 divided by pi degrees that you can use in your calculator now. Okay, we're getting closer to setting up the law of sines. The next thing that I want to do is identify what to solve for, and it'll be y, the whole length here, which means I also need to find out what this angle is, alpha, because that's opposite the side y. Well, to write the law of sines, I want to start by putting down the unknown, which is y, and then it's going to be the sine of alpha. The sine of alpha is just going to be 180 minus the other two. So I'm just going to write that in. It's the sine of 180 minus, in parentheses, 26 plus, and then 1.1 times 180 divided by pi. I know that looks cumbersome, but it's exact. We're not rounding as we go through. You can also store that answer in your calculator and then use it. So y over the sine of alpha is equal to, and then it's going to be 20, which is the side length, over the sine of the opposite angle, which is 26 degrees. I'm not going to do the calculation, but you would multiply by the denominator here, and you're going to get an answer for your y. And once you get an answer for your y, you really want to know what your x is. So to find your x, it's going to be approximately whatever you get for y minus 20. It's the whole minus the part gives you the other part there. And then that would give you the correct answer. What did I have to remember here? Definition of radian. I had to remember how do I convert radians to degrees, and then I had to remember how to use the law of sines, matching up the angles with the opposite sides. Problem number 2. This is number 26. And what I want to do is read the problem, and at the same time, I want to go ahead and fill in the parts of this diagram. So it says, angle of elevation. A person standing on the street looks up to the top of the building and finds the angle of elevation is 38 degrees. She then walks 1 block further away, 440 feet, and finds that the angle of elevation at the top of the building is now 28 degrees. Meaning, this is 38 degrees, this is 440 feet, and that is 28 degrees. Angle of elevation from the horizontal up. How far away from the building is she when she makes her second observation? Her second observation, which means to the top from the 28 degrees. So how far is she from here when she makes that observation? Well, to find this, this makes sense because 38 is a bigger angle, it's steeper, so it should be on the inside. To do this, you're going to need 2 different equations. You're going to have to find the obtuse triangle out front, and then you can work with this triangle. Don't make the mistake that you can mix 2 triangles when you're using the law of sines. You can't. You only can work with the same triangle with the law of sines. So I want to work with that obtuse triangle. I have a side here. I need to know what this angle is. And that angle, I can make an observation here. I can say, you know what? To that little dot, 38 is supplementary to that dot. But these 2 angles are also supplementary to that dot. So these 2 have to be the same thing as that exterior 38. They're both supplementary to the dot. They have to be equal. So this equals these 2, which means this has got to be 10 degrees. Now, if you don't like that, you can always say the dot, I'm going to subtract 180. I'm going to subtract 38 from 180, and I'm going to add the 2 up, and then I'm going to get 10 after that. So you can work around that, but you get 10 degrees on that upper angle, and then that takes care of one pair. The other pair is where you're going to get 28 and find out what this side is, x. And then what I need to do is solve for y. And what I really want to remember is what is that length right there, because it's asked for this from the second observation. All right, so there's a lot going on here. And again, I have to focus on what it's asking me for. It's the whole length on the street. So let's go ahead and make the law of sines. I want to put down what I'm looking for. X is to sine 28 as 440 is to the sine of 10. That's going to give you your x. Once you get your x, you need to make a different equation and work within the right triangle. You're going to see that your 38 is in a right triangle. I apply SOHCAHTOA. This is going to be adjacent over hypotenuse, which is cosine. So it's cosine 38 equals your y over what you got for x. And then you solve for y. Once you get your y, you're going to remember, oh yeah, I've got to add the 440 to it. So the distance is equal to 440 plus your y. Again, I really think that if you're able to set up this law of sines, the rest of this you should be able to get at this point. It's more of the setup and getting started. Let's go to the third problem, and we have two more. Number 30 says, again, angle of elevation. A 150-foot antenna is on top of a tall building, 150 feet. From a point on the ground, the angle of elevation to the top of the antenna is 28.5 degrees. While the angle of elevation to the bottom of the antenna from the same point is 23.5 degrees, meaning this is 23.5 degrees. How tall is the building? I want to write down what I'm solving for. What is my x? Buildings are perpendicular to the ground. Well, one thing that I notice on here is this is my length. Again, I have to work within that obtuse triangle at the top. To do so, I have to know what is this angle, that small angle, which is the difference between the two. So many students will get confused within this part right here. So be very careful with that. This is going to be 5 degrees, because when you subtract them, you get 5. Then you have an angle, you have an opposite side. I'm still missing some information. The information I'm missing is going to be this angle right here, because I know what the whole angle is. And I know that plus this have to be complementary. They have to be 90. So I know this is going to be 90 minus 28.5. And that's going to give me 61.5 degrees up on top here. Now I have two angles and a side. I can use the law of sines to get my y in order to get my x again. So we still have the two equation situation, which means I want to write down what I'm solving for. Y over the opposite is going to be sine 61.5 equals 150 over the sine of 5. You write that correctly. Solving it should be easy at this point. I know what I can get for y. Now I can get my x. We're looking at opposite over hypotenuse, so that is sine. So then it would be sine of the smaller angle, 23.5, is equal to x over what you just got for your y. And then you can solve for that x. And there's one more problem I'd like to look at, and this is the problem that's like the helicopter problem. Number 34, distance to a rocket. Tom and Fred are 3.5 miles apart watching a rocket being launched from Vandenberg Air Force Base. Tom estimates the bearing of the rocket from his position to be south 75 degrees west, while Fred estimates that the bearing of the rocket from his position is north 65 degrees west. If Fred is due south of Tom, how far is each of them from the rocket? I would say a real important starting point on this is in the last question. And it says, if Fred is due south of Tom, that tells you you're talking north-south. It tells you where Fred and Tom are. So it allows you to mark in Fred here and Tom here. Once you have that, you also know you're talking 3.5 miles apart. And it says the bearing from Tom's position is 75 degrees southwest. Now, south has to come off of this side because you're swinging it to the west. So it's that right there is 75 degrees. Even though it's on the north side, you're going off of the south line for the bearing. Fred is going to go off the northwest, so that's going to be like this, and that's going to be 65 degrees. 65 degrees north, 65 degrees west. Before, when we did this problem, I would have to draw in this line to make right triangles. And then I said, okay, one is x, the other one is 3.5x. I made two separate equations, two equations, two unknowns, solved for them, got my x. Now it's much easier because we can use the law of sines here. And you're going to see the question is, what is the distance from Tom to the rocket and from Fred to the rocket? So you're going to have your x and your y there, and you're going to have to do the law of sines twice. So one is to focus on your x. The only problem is you have to know what that angle is. That angle is going to be 40 because it's 180 minus those two. Now you can go ahead and write it. X is 2. The sine of 65 equals 3.5 is to the sine of 40. Solve for x, and you can probably figure out how to solve for y doing the same method. Setup is important. You have to be able to use previous knowledge. We now can work with non-right triangles. Next section, we're going to be looking at something called the ambiguous case, which means that it's not so clear when you're applying the law of sines.